Good afternoon, everybody. Welcome to our afternoon side event on ocean acidification in the Persian Gulf, the Red Sea, and the Mediterranean, scaling down risks and scaling up solutions. At the beginning, let's warm up a little bit and ask some questions to the audience. So it's just lifting your hand or not lifting your hand. So would you say you have a good understanding of the concept of ocean acidification? If yes, please raise your hand. Great, thank you very much. Would you say you are concerned or worried about the impact of ocean acidification has on human society? Thank you. Um, And if you at some point get bored during our side event, you have a little QR code on your seat. You can scan it, and there are some questions which you can answer. So about where you come from, what your background is, to get a little bit of knowledge of the audience. So at the beginning of our side event, I would like to start with a video. Could you please play the video?
It's a huge time bomb waiting to explode, and we still don't know enough about it. These IAEA scientists and their colleagues around the world are working to change that.
This acidification has negative effects on a lot of the life in the ocean, including shellfish and corals, and a lot of fish that we like to eat. So aquaculture and fisheries are greatly affected.
The ocean absorbs a quarter of all CO2 emissions. This helps mitigate climate change, but it also means paying a heavy price.
When the carbon dioxide is dissolved in the water, there's a chemical reaction that causes the ocean to become more acidic slowly. And as we add more and more carbon into the atmosphere, the water is getting slowly more and more acidic.
The resulting acidification is threatening fragile marine life. Calcifying organisms such as oysters, crabs, sea urchins, lobsters, and corals struggle to form their shells and skeletons. And studies show that some of these organisms start dissolving in an increasingly acidic marine environment.
The organisms in the ocean that will be impacted in terms of things like increased mortality, their sizes might change, their ability to deal with threats and predation might be impacted as well.
It is not just marine life that is impacted. Over 3 billion people depend on the ocean for their livelihoods.
Ocean acidification is, of course, a phenomenon that is much harder to portray, harder to see. Yet it is now a reality whose economic consequences are directly perceptible and whose effects could be devastating in the long term for many sectors, starting with farming and harvesting of many shellfish and crustaceans, already severely impacted.
According to the latest report of the UN's Intergovernmental Panel on Climate Change, scientists predict that by 2100, the ocean could become 150% more acidic and affect half of all marine life. There are many challenges to addressing ocean acidification, and one of the big ones is that it's a global issue.
Our oceans are completely all over the planet, and because of different influences from rivers and the ocean chemistry varies a lot regionally, that if you measure ocean acidification in one place, you can't understand ocean acidification for the whole globe, which is why it's really important to have a global monitoring presence throughout the world for ocean acidification.
This is why the IAEA runs a center to drive global ocean acidification activities, following increasing concern from member states about the issue.
At IAEA, the Ocean Acidification International Coordination Center really focuses on the science of ocean acidification, as well as communicating the dangers of this issue and building capacity in really vulnerable developing regions of the world. And this is really crucial so that they can understand the chemistry conditions in their waters and then make projections about how this chemistry is changing and how it will impact the industries and seafood species that they really care about.
Monitoring is essential to understand the extent of the problem, But is there anything that can be done concretely to combat ocean acidification?
It's very simple and very difficult to achieve at the same time. The simple solution is avoid emissions and decrease energy consumption. There is no quick fix.
Alongside global momentum towards the need to reduce carbon emissions, the studies being done in Monaco and at labs around the world are also examining potential solutions to the issue. One of these is alkalinity enrichment to counterbalance acidification. Nuclear science allows researchers to trace key elements like calcium and learn more about coral growth. One possible outcome of this research is finding small-scale solutions to reduce acidification in key shellfish growing regions.
And this combats the acidity locally, so this can be a really effective way to improve shellfish aquaculture or coral reef restoration projects.
But even more importantly, such research gives policymakers the data and insight they need to drive forward climate policy and actions before it is too late.
So this video was possible thanks to the great film team of IAEA and gives a little indication why at IAEA we are working on ocean acidification. Next slide. Oops. So in addition to using nuclear techniques to, for example, do experimental work to assess the impact of the ocean acidification on marine life, but also to assess in a small scale the effects that alkalinity enhancement could have on marine ecosystems, we are hosting the Ocean Acidification International Coordination Center. And this is a hub for coordination of international activities on ocean acidification. It was launched in 2012 at the Rio+20 conference as a reaction of the increasing concerns by member states about the impacts of ocean acidification, not only on the ocean, but also on coastal communities. And as it has been said in the video already, we are addressing science, we're doing research, very important capacity building and training, tailor-made to the needs of the member states, and communication. But this session today is not about the Ocean Acidification International Coordination Center. It's about ocean acidification here in the region where we are today. So with this, I would like to introduce our dedicated speakers today. And it's a great pleasure to introduce to you Montaha Behbahani. She is research specialist in the Environment and Life Sciences Center at the Kuwait Institute of Scientific Research. She has more than 40 years experience in using radiometrics as a tool for climate-related and anthropogenic impact studies. Her current research on response of marine organisms to ocean acidification and ocean warming shows resilience of organisms to climatic stressors in the Gulf region. So please give an applause to Ms. Behbahani. Our next speaker is Dr. Natalie Hilmi. She is an expert in macroeconomics and international finance, and she, since more than 10 years, is head of the section of environmental economics at Centre Scientifique de Monaco. She has a strong collaboration with the IAEA Marine Laboratory on socioeconomic impacts of climate change and the cost of action versus cost of inaction. And she is a lead author of the IPCC Special Report on Ocean and Cryosphere in a Changing Climate and the IPCC Main Report R6. Please applause. Our next speaker is Jessie Turner. She's Executive Director of the International Alliance to Combat Ocean Acidification. The Ocean Acidification Alliance is a voluntary initiative of national and subnational governments to raise the ambition for climate action and to transform the global response to climate ocean change. Our fourth speaker, I'm very pleased to have you here, is Professor Steve Widdicombe. He's Director of Science of the Plymouth Marine Laboratory. He is co-chair of the Global Ocean Acidification Observation Network Executive Council and co-lead of the UN Ocean's decade-endorsed Ocean Acidification Research for Sustainability program. And he's the focal point for the UN SDG community on Ocean Action 14.3. Please, an applause. Our fifth panel member, she is still in a panel downstairs, and this is Lina Hansen. Lina Hansen works with the Prince Albert II of Monaco Foundation, where she is a coordinator of initiatives on environmental conservation from terrestrial freshwater to marine ecosystems. She is also coordinating the OASIS initiative, Ocean Acidification and Other Ocean Changes and Impacts and Solutions, led by the Foundation. And their work on impacts of ocean acidification in a multiple stressor context, as well as potential solutions to mitigate the impacts. And she was the former Associated Project Officer of the Ocean Acidification International Coordination Center, which we are having at IAEA. Please give an applause to her absence. I hope she will be able to join us later. So now I would like to start with a kickoff presentation. So each of the speaker has about 5 minutes to give your statements. And we will start with the statement of Ms. Motabeh Behani. And Motabeh Behani will give an insight on the acidification and warming in Gulf waters. Please. You could also come here if you want.
Yes, it's be more easier.
Yes.
You can see the slides. Hi, good evening. Just to give a brief information about the Gulf. Gulf is the 251,000 square meter connected to the open sea area by the Strait of Hormuz. And the fresh waters they're coming from northern, from river Shat al-Arab and Karun and Shat al-Basra. Gulf is around 989 kilometer along the, and the width is, this is the long, and the width portion is be 300 kilometer, and the northwest is be 56 kilometer. The water was overall very shallow, with maximum depth of 90 meter and the average depth 50 meter. Residence time of the Gulf water is around 2 to 6 years. Excessive, desalination activity goes on the Gulf, and they have the sea surface temperature is quite variable, and it is often very high. High input of the nutrients and the ocean period activity. The higher NICs and SOx absorbed in the marine area. The acidification in the Gulf water, the acidification in the Gulf water, and loss of the fisheries and biodiversity. The frequent dust storm, the one of this also the contamination of the deposition of the contamination of the dust. Sorry. Then this is the area or the map for the Gulf and the quantity of the desalination water, which is around 11 million per cubic for the desalination, the Gulf, the desalination and the temperature and the trend of the observation station in the open Gulf North Kuwait. This is the map of the temperature and the salinity. Next. And then we have the coral reefs in the Kuwait. Still, there's some, some coral still is by effect of this acidification, but still it is on the good condition. Next, sorry. And this is the picture of this the bleaching and the observed in these corals. So next. And this global acidification observed. This is there's only the two countries which is be precipitated in the region that in this region it is Kuwait and Iran, or Public Islamic Iran. And so the data set are quite limited. So next. This is our assessment lab, in the Kuwait, in Kisar, our Kuwait Institute for Scientific Research. This is our lab, and when did we prepared our sample. This is in our lab. So next. Then also this is also all the equipment and the technique which is be used by analysis of the sample and the next. This is the to understanding the classification machine of the major coral and the coralline algae species inhabiting and the Gulf, Arabian Gulf, to assess the response of the ocean acidification, climate change in the term of the surviving dissolution and across classification and photosynthetic and respiration rates. To evaluate the growth and the surviving of the shellfish and in the Gulf, and to assess the food conservation ratio under different acidified conditions, to an understanding of genetic adaptability to changing ocean acidity and temperature. Testing organism example as copyboard show the adaptation in the form of different up and down regulation of the certain gene related to the temperature, stress, and pH in the multi-generation experiment. Understanding bioavailability of the metals under different ocean assist the microplastic and the coastal water. Thank you very much. Thanks. I think next thing and this. Thank you. Thank you. بارك بعمرك.
So now our fifth panelist has arrived, Lina Hansen. The next presentation will be given by Natalie Hilmi. You have 5 minutes to make your point, please. You have the head.
Yeah. I think I can talk. Is it okay? Yes. Okay. You can hear. I don't think it's. Okay. Can you hear me? Yes. Okay. I'm going to present about the ocean acidification risk and impact in the Mediterranean, and about the socioeconomic aspects mainly because I'm an economist, so this is part of my work. We know that the Mediterranean Sea is surrounded by 23 countries that plays a vital role in trade, tourism, and food supply. The Mediterranean Sea is accommodating 20% of global seaborne trade, contributing to 10% of the world shipping container throughout. And also the Mediterranean tourism represents 33% of the world tourism. So this is very impactful. And next slide. Yeah, thank you. IPCC report is very clear. The Mediterranean Sea is getting warmer. It's acidifying and it is deoxygenating. And those together will bring many problems. Next slide, please. I'm studying the socioeconomic impact of ocean acidification. I started in 2009, Monaco Scientific Center with the IAEA in Monaco. And we can use direct indicators like productivity, employment, income, and trade, but also some indirect we study the indirect impact with the carbon sequestration, for example. And this is very important because now when we consider finance, we consider the carbon market and the carbon credits. And this is a very important field of research. And I'm studying blue carbon, for example. In the Mediterranean, it has an impact. Next slide, please. The most vulnerable economic sectors to ocean acidification are fisheries and aquaculture, tourism, and recreation, and red coral harvest. Next slide, please. We can see already potential declines in marine productivity, shifts in species distribution, and the local extinction risk for over 50% of exploited fish and marine invertebrates around 2050. So I have a study on the Mediterranean fisheries, and we can see that the fish are going upward to the Europe, meaning that the most vulnerable countries in North Africa will suffer more because of warming, but because also of ocean acidification, the impact especially on the seafood. And next slide, please. No. Yes. No, it was fine. Just one slide. Thank you. The impact is also important on human health, not only through protein intake, but also because of the impact on the different ecosystems and the food chain. Next slide, please. And this will have economic cost that we are trying to assess. And this is essential on seagrass, for example. This is Posidonia in the Mediterranean Sea, and it is crucial for climate regulation and blue carbon. Next slide, please. And this is what you see here is coralline algal habitat, and it is also impacted by ocean acidification in the Mediterranean, and we can calculate the economic impact of it. And next slide, please. What we can see is a lack of consistent OA policies in the Mediterranean. What we need is more coordination, more collaboration between the countries if we want to have very good impact. Thank you so much.
And the next statement is given by myself. So how the Global Ocean Acidification Observation Network, called GOAON, hub for the Mediterranean region, addresses ocean acidification risks. So the GOAON Mediterranean Ocean Acidification Hub is a grassroots initiative. It's a voluntary network that connects Mediterranean scientists who are working on and are interested in ocean acidification around the Mediterranean Sea. So this regional hub is supported by 90 members from 14 countries that border the Mediterranean Sea. And it has an 11-member steering committee with 2 co-chairs and a secretariat member. So what are the goals and the outputs? So the goals of the GOAON Mediterranean Hub is to improve communication to better study and understand ocean acidification and its regional consequences, importantly through collaboration and joint projects, so really action. And to promote, very important, consistent community best practices so that everybody uses the same methods and best practices and tools. And it supports the Mediterranean ocean acidification community also via capacity building and trainings. And it provides ocean acidification related policy briefs and also public outreach. The outputs, this hub is existing only for 1 year, and we have already a publication. So which you see, ocean acidification research in the Mediterranean Sea, status, trends, and next steps as a baseline. More joint published review papers are to come. There is an ongoing intercomparison exercise where 12 institutes are represented, measuring a suite of carbonate chemistry parameters. They're writing joint grant proposals, participate in international events and conferences, and write multiple annual newsletters, and are present in social media. This Mediterranean Goa on Hub is one of 9, or is it already 10 hubs around the world, regional hubs that are active, and all of them are grassroots initiative and voluntary. There is no external funding. And the next presentation will be given by Ms. Jessie Turner, please.
Thank you. Thank you, Dana. And thank you for having me here today to speak. Does this sound okay? Good enough? Okay, so I'll just give a quick overview of the OA Alliance. So we were created to help governments better understand and respond to ocean acidification impacts within their regions, both domestically and then also internationally. So we've been talking a lot about the science so far and how we need to fill knowledge gaps, take an inventory of what we know in different areas and what the impacts might be. But now we need to be moving that conversation into the policy and decision-making space. And so that's what I'll just quickly give the overview about. For next slide, I just want to mention that we really need to be doing this by beginning to put OA information in context. So we put OA information, knowledge gaps, mitigation, and adaptation strategies into perspective that policymakers, decision makers, and even other stakeholders that are non-governmental can understand, that they can engage with, importantly, that they care about, and most importantly, that they can do something about. That's a really big element when it comes to thinking about what can we do, what are we asking policymakers to do about this issue. And so we know, of course, that OA is a multi-sector issue. It's a multi-discipline issue, which is why it's really hard to bring all the right people together to figure out what's needed to take inventory of what we know about potential impacts. But here's just a quick example. You can see that we're talking about OA in a larger context, including climate adaptation goals and financing needs, including marine management strategies, including sustainable development goals, tourism, food security, and other things that I can't see, but I'm sure are right there behind me. And so we'll talk a little bit more, I think, in the panel about food security. So I'll save that for sort of our secondary question discussion. But again, just really want to help set the scene for putting this in context. So for the next slide, I also just want to mention that it's really difficult to go to a government or a policymaker or even a stakeholder and say, what are you doing to better understand and address ocean acidification in your region or in your country or in your community? It's a new question. Nobody has the right answers to that question because we're figuring it out together in real time. And so the OA Alliance, we've sort of set up this framework to sort of give some buckets for policymakers, decision makers, stakeholders to understand what we call like OA adjacent activities. And so the first you can see here is obviously just reducing CO2, the number one cause of ocean acidification. Secondly, looking at advancing that local science and research for purpose. So really thinking about moving from IPCC projections into something a little bit more fit for purpose locally. Thirdly, and this is really important, I think, for this discussion in the Mediterranean, is thinking about reducing local stress like wastewater, agricultural runoff, nutrients, nitrates, that can go a long way to exacerbating ocean acidification as well as hypoxia near shore, coastal acidification, as we refer to it. And this is one of the biggest things that we talk about when what can we do to reduce pressure today on ocean acidification. So it's really important that policymakers, decision makers understand the link between that action and ocean acidification stress reduction. Fourthly, adaptation and resilience strategies. We'll talk a little bit more about what those are, what those could entail. And then 4 and 5, I won't go into detail too much, obviously raising public awareness with multiple different communities. We remember the sectors that we saw on the last slide. So how do we communicate OA to some of those types of people that are operating within those lenses? And then international momentum building. And so Steve will talk a little bit more about what that work looks like for an OA research agenda internationally, but also thinking about financing and really beating the drum for increased finance for this work at a regional and local scale. And so We've heard a little bit about the impacts, and I think we'll talk a little bit more about impacts of ocean acidification in the Mediterranean and Red Sea areas across the Middle East. But what I want to mention here is that we do, through the Alliance, work with partners currently even in Egypt, the UAE, Lebanon, Turkey, Greece, Italy, France, but also partners like the Union of the Mediterranean, the European Commission, alongside regional seas conventions. So even conventions like the Barcelona Convention is also, the full title is the Convention for the Protection of the Marine Environment and the Coastal Region of the Mediterranean, as well as the Black Sea Convention. And it's really important that we're also engaging and connecting with these types of partners to find a path forward to regionally appropriate and applicable policy strategies that best support localized OA mitigation and adaptation. And so this slide is my final, and I promise I'll just highlight a quick project that we've been working on with the European Commission and its member states, and I think it has some applicability to the conversation we'll get into. Here in this example, we've been working to help identify which regional seas conventions are actually generating OA information now, which are not. What gaps do we need filling, where, and why? And then, really importantly, how does OA information, and that includes measuring, reporting, mitigation, and adaptation, fit into some of these existing shared management policies that are already in place? The European Commission's a little bit more attainable because it's a shared directive across all EU member states. But to give an example, here we're really helping them think about how does OA information support something called the EU Marine Strategic Framework Directive, which asks governments to assess and report on the status of their waters and determine if they are in good environmental status. And of course, none of this has any consideration around warming, acidification, oxygen loss. And so really helping them think about that, as well as connections to the Water Quality Directive, Nitrates Directive, as well as biodiversity targets and goals. So really, how do biological diversity targets and goals, when we put that in context of food web impacts, habitat compression, and food security, what are we missing when we're looking at those types of goals and targets locally? So I'll just pause there and we get into the other questions, but I just want to highlight this is the type of work, particularly in the Mediterranean, that would be very applicable currently, but thinking about what other shared conventions or directives can be exploring in the region as well.
Thank you very much, Jessie. So the next statement will be given by Steve Widdicombe on global coordinated actions to address ocean acidification. So ocean acidification research for sustainability, called OARS.
I think I'm tethered to the chair with this thing, so
You can also. Oh yeah.
I'll sit here. So
You can stand up.
I can sit. Oh, okay. There we go. Have you got that
Yes, I
one?
got it.
Okay, you got double hand there. Okay, right. How could this go wrong? Okay, so global coordinated actions. As you heard earlier, I co-chair the Global Ocean Acidification Observing Network. I also am a co-lead on the Ocean Acidification Research Sustainability Program endorsed through the UN. So I'm going to give you a little bit of a perspective on how I see ocean acidification activities, both in terms of a global perspective, but also how that resonates down into what actually happens on the ground. So kind of next slide, please. So as we've thought, ocean acidification, a global phenomenon. It's happening in all the oceans all over the world. Wherever we go and measure it, we're seeing that ocean acidification is happening. But as a global problem, we recognized in 2012 that actually the best way to then address it was to collectively come together as scientists who are interested in this problem and share our knowledge, share our expertise, work together on group activities, because time is pressing with this matter. It's not something we can spend the next 50 years looking at and understanding how to deal with it. It's something that needs to move quickly. And the way in which you move quickly is you move quickly together. So we came together in 2012. There was around 60 or so scientists from a dozen countries formed the observing network. And we are hugely thankful for the support given by the IAEA, who have been funding the Secretariat along with partners from NOAA and IOC UNESCO for all this time. And without that support, those coordination actions really just don't happen. But as you said, other than that coordination, the rest of the activities that go on within GOAN are voluntary. These are people who are committed to ocean acidification and want to do something about it. Now, when so if we click on again, so then go back 5 years and the UN Ocean Decade was launched. And the UN Decade represented a challenge to scientists in the fact that we were then laid down the challenge that we needed to do science and provide science that was transformational and just didn't think about doing science for the sake of science. So as the sort of global coordinating entity of so many scientists, so as you see in 2023, GOAN is now represents over 900 scientists from over 114 countries. We felt it was our responsibility to create a roadmap for how science could engage with solutions and new policies to be able to make a difference. And we did that by creating this, in essence, what represents a roadmap, the science and the activities we need to create a real change by the end of the ocean decade. And we did something unusual that scientists don't often do because we are so interested in doing science because science is really cool and it's really interesting. And we're only really interested in the next piece of science in front of us. But what we did was we actually said, okay, if we're going to get somewhere, we need to know where we're going. So we laid out what it was we wanted to achieve by the end of the decade. We thought about the ultimate benefits. We thought about the impacts. And then we challenged ourselves to go, okay, so what do we really need? As the Ocean Decade said, what do we really need for the ocean we want? And we identified these outcomes. There are 7 key outcomes that our actions must deliver by the end of this century if we are going to deal with the ocean acidification problem. We need to generate the quality data that's required so that we can understand the problem. We need to also understand what the priorities are. As I said, there's so much to do. But we need to focus on that science which can be taken into policy and can affect change. So it's not about doing everything everywhere all the time. It's about doing the things that really matter. So how can we partner and co-locate ocean acidification work with other environmental science so that we get more value for our money, more value for our investment? We all know how hard it is to get funding to do these kind of activities. How can we get more out of it? Understand the biological impacts, because at the end of the day, chemical changes in the ocean are all very interesting, but it's really what's affecting the biology and the humans who depend on that biology that really leads us to take action. Future projections. And this isn't about generating ocean models of the entire basin, because if we're going to manage this problem, we need to manage the resources at a local level. So we need to create models and future predictions and scenarios that really matter on a scale where people can make decisions. Public awareness. Public awareness is not about turning everyone into an ocean acidification expert, but it is about giving people enough information so that they can have contribution to the conversation. And when we move on to the next outcome 7, when it's about putting evidence into policy, we then take the public with us, because some of these policy decisions won't be particularly pain-free when it comes to the impacts on people. So people need to understand why they're being made and actually being supportive of the fact that what we're doing is trying to make things better. Next slide, please. So how can we all be part of this effort? So in terms of being part of OARS, well, OARS was created by GOAN, but it isn't GOAN. It's intended for the entire community. And whether you are a marine biologist, a chemist, a social scientist, a policymaker, a professional communicator, whatever your training, you can play a role here. For each of the outcomes, there is a working group, and we call people to come and join these working groups as be part of ones. And you can contact us and become part of these working groups. Next slide, please. We can also create projects. If you're working on ocean acidification, and if you want your work to be recognized and be contributing to this international effort, you can get your project endorsed by the UN Ocean Decade and come in under the umbrella of OARS. And The types of activities we're looking for in each of these outcomes is laid out in a series of white papers, which will be published soon, and you can refer to these. But equally, OARS as a community is happy to work with you as you develop your projects to ensure that they are fitting in line with the types of things we want to do so that you have good success when you go for endorsement with the UN decade. Next slide, please. But we understand not everyone wants to go through the formal endorsement phase. So we've just launched a process whereby if you are working on any aspect of ocean acidification, you can register that as a voluntary commitment through OARS. So you can show the world what you are doing. So you get recognition for the work you're doing, show how it is contributing to the international effort. But also by doing so, you are also playing your part in inspiring others to do the same. Because if they see what you are doing, people will say, I can do that as well. I want to be part of that. And momentum builds and more people become involved. Next slide, please. Okay, so that's not mine. So in essence, what I would like to sum up and saying is that this effort of coordination is not just there for a group of scientists, it's there for everyone. And we really do want to reach out and bring as many people into this conversation as possible and use everyone's skills to deliver those outcomes, because you do not deliver change unless you really engage with those people who have the skills to be able to do that. And I think the Ocean Decade has been key to getting scientists to step out, create new partnerships, and really engage in a collaborative way with those people who can really help affect change. So thank you very much.
Thank you. Thank you very much, Steve. So as you can see, global ocean acidification is a global problem with different regional impacts. We can only tackle it if we have really globally wide activities and bring the community worldwide together. And we submitted a satellite event to the Ocean Decade Conference in Barcelona together with OARS, the Ocean Acidification International Coordination Center, together with OARS, and go on. And we really hope, please keep fingers crossed, that it will be accepted, that we can have a big successful satellite event in Barcelona. Thank you very much, Steve. Our next speaker is Lina Hansen, and she will tell us about enhancing research capacities for ocean acidification and multiple stressors, for example, warming, which is an effect of global change, climate change, and pollution, to underpin targeted sustainable solutions. Please.
Thank you so much. Oh, wow. This was more efficient than yours. I'm very happy to be here again. Sorry for my slight delay in the beginning of this session. I'm Lina Hansen. I'm with the Prince Albert II of Monaco Foundation. And we are working closely together with the IAEA, Ocean Acidification International Coordination Center, with the Scientific Center of Monaco also represented here, and with Jesse and with everyone basically on this panel. And we have I also before joining the foundation, I was working with the OA-ICC. So I have been following these from the start, and it's very nice to be able to be here on the panel. I think it fits super good after your presentation, because you're talking about the skills we need to deliver the future we want and the decade, and how do we build those skills. So it's all about capacity building, of course, and the IAEA is a huge player in that regard, and the Ocean Acidification International Coordination Center has been one of the main organizations to be delivering capacity building to member states all over the world for the last more than 12 years, actually. Yeah, soon. So what my slides are not really, they're just humans on these slides. I just want to, show people, because there's where the skills ultimately are needed. This is a particular course that we were organizing on multiple stressors last November. So it's not specifically focusing on a region. And I wanted to, before going into this specific course, I just wanted to say what we have learned through the capacity building development and the activities of the OA-ICC in the past. So today, the OA-ICC has funded or provided capacity to more than 800 scientists all over the world. And through more than 60 capacity building opportunities and more than 100 countries. So it's really a big, big effort. And before the OACC, there was nothing really on capacity building on ocean acidification. So this has been, the ocean acidification community has been very strong in coordinating itself and saw very early on the need to involve everyone and leaving no one behind. So that has been one of the key features of the OACC since its start. What we have learned is in the early days we started with very basic courses, which are very useful even today, because what we see is that we need to build capacity in different steps. So in the beginning we had more we started out with more theoretical, let's say, courses on carbonate chemistry, on biology, and some demos in the lab, but not really hands-on. When we felt that participants had gone through that stage, we were able to engage them in the what we call level 2, which is more like interactive, let's say, where people are well, our participants would really engage in lab studies more. Then as they acquire this capacity, what we designed together with Sam Dupont, who is really I want to acknowledge. I think he's on the, let's say, second slide. Maybe we can see him well. No. Well, we can see his head there. You know, he has very been really been a champion of this particular activity of the OACC. He's with the University of Gothenburg. He's also a consultant with the IAEA now, and he has been we're developing together this really comprehensive capacity building program. So building from that level 2 training, what we did was realizing that we could bring everyone together around a common experiment. So that was the third step of training that we are offering, let's say, that we actually do longer training courses around 2 or 3 weeks. Here you have some just pictures to illustrate some of those courses. This is a picture in Villefranche. We try to bridge field studies with laboratory experiments and really to conceptualize how to do ocean acidification experience. And what is really important is that each time we try to encourage participants to think about what is important in their region. So this is very relevant for this session, of course, when we talk about regional approaches. As Steve mentioned before, the goal is not that every scientist in the world measures ocean acidification in every point in the world and do the same thing. It's really important to understand what are the problems from ocean acidification where you are, and that scientists can to build that local capacity to respond to those concerns, food security concerns. And others. So it's really about looking at what kind of data is existing, how is the chemistry, carbon chemistry evolving in that region, what do I need to measure? So we, during those training courses, we try to build on a number of resources that the OACC has also developed. We have a bibliographic database with all papers published on OA, a news stream as well with all information coming out from ocean acidification. And those can be, you can search for what you really are looking for in your region. So we try to do and have everyone doing a bit of a case study using these tools, which are really invaluable to the community, looking at what exists, what kind of data exists already in your region, and what so doing a mini analysis of what is already there and what you want to research what is not there already. So we're trying to do these courses around actually a true experiment. So this bringing people together, giving those basic tools to study together and then actually design their training course around a joint experiment, which means that people have all actually been able to publish scientific results together at the very end of the training course. So it's really exciting to see this community developing. At the IAEA, the final step maybe is see a coordinated research project that is also existing, which is really scientists all over coming together to respond to a specific scientific topic, a real mini research program. So there are different steps of that learning curve. I think we have been very glad to see how well it has worked over the years. And also moving, as Jana said, into multiple stressors, because obviously it's not only about OA. Ocean acidification is not happening in isolation. We need to look at temperature rise. We have in the Mediterranean, for example, there have been many heat waves in recent years. So it's really not about one single stressor. But that is so much more complicated, right? If you have more than one stressor, the complexity of the design of the experiment is not the same. So we're working also to try to develop best practices on how to do that altogether. I think I'll maybe stop here. Thank you.
Thank you very much, Lina, for your intervention. And with that, we are arrived. First, give an applause to our speakers. And now we are starting our panel discussion. So we have heard a lot of research, a lot of work going on after this almost 12 years of international, global-wide research on ocean acidification, concerted action. Allow me a little provocative question. What did we learn? So what progress has been made after this, not 12 years, but ocean acidification study started 20 years ago? So what progress did we made? So for the decade to come, what research should we prioritize? Which of you would like to take the question?
First, hadn't I?
Yes,
Okay.
please.
Well, actually, ocean acidification research started around 20 years ago. When it first started, it was seen as an open ocean chemical problem, and it was really just chemical oceanographers thought, "Oh, this is quite interesting. The changing in pH, carbonate chemistry, and what have you." And a lot of effort was gone into really understanding, being able to measure at very fine scales and understand very small changes. But what we've realized over the last 20 years actually is that where we should really be worrying about ocean acidification is in the coastal zone, close to where humans and the marine environment interact. Because whilst the biggest driver of ocean acidification is indeed carbon dioxide, but there are all sorts of other processes within the coastal zone that can make it worse. And things like wastewater incursions into the coastal zone, the way in which we add nutrients, the way in which but there's also solutions there, the way in which we manage habitats that can absorb carbon dioxide. So this is not an open ocean esoteric problem existing thousands of miles away. It's happening on people's doorsteps, and we understand now the complexity of the way in which organisms respond. When we first started, it was a case of, well, obviously those organisms that use calcium carbonate for their shells and their skeletons, they're going to be the ones most at risk. And we thought because it's just a dynamics between calcium carbonate and acidified water. But it's far more nuanced than that. We know that animals have got an ability to respond to the ocean acidification. And it becomes then a balance between the physiological choices animals make between, do I use energy to build my skeleton, or do I use energy to grow bigger or to reproduce, which can have huge impacts on aquaculture and fisheries. So the more we look into it, the more we understand actually it's a very complex problem, and it's very, very locally, contextually based. So not only are the impacts going to be heavily affected by what happens in the local area, but solutions as well. Many of the solutions are going to be driven by those processes that we can control by local management. So over and above controlling emissions, which is the one most important thing we could do, control emissions, there are other things we can do on our own doorsteps, which will give us the ability to at least reduce the impact of ocean acidification that we're gonna feel. So it's not a completely hopeless situation.
Thank you, Steve. Anyone from the panel who would like to add?
Yes, maybe I can add from the socioeconomic side. What we need is to understand the science and then make the evaluation of the economic impacts. And this is very important, the link between science, economics, the society, to understand everything together. And this is why the research should be multidisciplinary. When we talk about climate change, about ocean acidification, the twin evil, the multidisciplinary research is really crucial to understand and to find solutions. If we want to take the right decisions, we can tell the policymakers that this will impact the ecosystem, this will impact the biodiversity and so forth. But in fact, if they don't understand the cost of action or inaction, they will not take the right decisions. And it is very important for them to understand that if they don't act now, if they don't stop their emissions, their carbon emission now, it will be much more costly in the future. And this is what we call the cost of inaction. And for ocean acidification, we know the impact, most of the impact. We still have research to do locally to understand more. But what we need now is solutions because policymakers at a certain moment they tell us, okay, we understand, but now what can we do? And we have to bring them solutions on the table. And for example, it can be technology like alkalinity enhancement, but it can be also nature-based solutions. And as I said, in the Mediterranean, we have the Posidonia, the seagrass, and it can capture the carbon sequester in the ocean. And this is very important.
Thank you, Natalie. You addressed already the question I was about to ask or started to answer. What about the progress in solution design and implementation? So maybe you could, the panel could address this. So, what do you think about ocean alkalinity enhancement? I know there was a session yesterday in the ocean pavilion, but maybe some of you would like to elaborate a little bit more on the potential impact on ecosystems and organisms?
Ah, I can open.
Okay.
Okay.
Go ahead, Jessie.
All right. Only because I spoke on an ocean alkalinity enhancement panel yesterday from an ocean acidification perspective. I would say through the OA Alliance perspective on this particular topic, we talk about marine carbon dioxide removal strategies in general. And I think for as this issue or these sort of topic was getting more focus over the last couple years, we were really nervous that ocean acidification trends would be pointed to as sort of a carte blanche sort of calls for increased marine carbon dioxide removal as sort of a go-to, lightning solution. And we certainly don't think that is the right approach to this topic. And that said, we also know that we are going to need some carbon dioxide removal strategies, atmospherically land-based, and perhaps from the ocean. And also, we know that not all marine carbon dioxide removal strategies are the same, and they will have different impacts on ocean acidification, sometimes decreasing ocean acidification, maybe accelerating acidification. And that's going to look different global and local and regional scales. And so, what we spoke about a little bit yesterday is the potential for something like a localized ocean alkalinity enhancements to be something that's less about the sort of larger scale, carbon removal, capture, storage measures measure and monetize, which is sort of, I think, the way that that conversation is headed, but also a little bit more about a local adaptation and resilience building opportunity. So if in fact there's areas where we can get that lagoon a little bit more time or that reef a little bit more tolerance during certain seasons of stress, or that shellfish growing operation or urchin farm a little bit more resilience during periods we know are going to be a little bit more stressful, or during life stages that are going to be a little bit more vulnerable, then it is worth exploring some of those strategies to think about what that could look like from our perspective. I think the biggest thing is recognizing that in a lot of areas, we've talked a lot about the regional knowledge gaps, right? So we've got global IPCC projections. Steve said eloquently that we need to be bringing ocean acidification work to the coastal zone margins. And in a lot of areas, there's just no baseline when it comes to even evaluating what the trends of ocean acidification have been, what the carbon cycling has been in a certain area. And so that is one consideration when we think about localized strategies for OAE. Is it occurring? Are these pilots occurring in areas that actually have baselines that we can measure against? And if not, are there ways that we can encourage some of those private sector or private sector dollars to support that type of research, to support that type of baseline development regionally? I guess that's monitoring more than research. So that's sort of the perspective, I think, around its application potential for localized relief, localized resilience, but probably a long way to go to think about exactly what that could look like. And again, it's so particular, case by case, location by location. And that's outside of my wheelhouse quickly as a non-scientist to get into. But
Maybe Steve, as a hardcore scientist, would like to add.
I completely endorse everything that Jesse said. The key thing I'd focus in on is that we talk a lot about marine or ocean carbon dioxide removal as if it's one single thing, but it isn't. It ranges from conversations being had around the restoration or the protection of natural habitats that are drawing down carbon dioxide, which we know a huge amount about now. And actually would appear to be a relatively good thing to do to protect those habitats, all the way through to techniques such as the alkalinity enhancement techniques, which is around manipulating the chemistry of the ocean, but with the intention not to be then changing the biology, all the way through to proposed techniques which purposely manipulate biological systems on vast scales to be able to drive carbon dioxide removal. Each of those things come with a set of risks and a set of benefits that still have to be explored a lot more before we start making decisions. It's imperative that decisions we make in this space are evidence-led, and we don't act out of out of hope rather than out of knowledge. So we mustn't let our hearts rule our heads that we just want to do something and this seems like something we can do, so let's do it. Let's make sure that we're doing something that's going to benefit us and the oceans, and we're not in essence creating a bigger problem than the one we're trying to fix. In essence, when we start licensing activities like this in the open ocean, we're kind of writing a patient consent form for the ocean. Now, if you think about a pharmaceutical intervention or a medical intervention, if I was to come to you and say, I've got a new drug that I would like you to take, your first question to me is it safe? Is it going to make me better, or is it going to make me worse than I currently am now? Currently, for many of these things, we don't know. So why would we sign off that patient consent form for the ocean until we understand what those side effects are? I think that would be negligent on our part, and which is why it was fantastic. Yesterday, there was the launch of the best practice guide on how we do the research for ocean acidification. I'm sure Lena will talk a bit ocean alkalinity enhancement experiments, and I'm sure Lena will talk to you a bit more about that, because what we've learned is we need to act quickly, but we need to empower the scientific community to be able to give the evidence that's needed. There's no time to waste. So resources like that are going to be fundamental in ensuring that we're not scratching around for knowledge and we can make better decisions, and we don't find ourselves in a much worse position than we currently are. So I don't know whether you want to say something.
Yeah, thanks, Steve. No, yesterday, yes, we launched this guide to best practices on ocean alkalinity and research. And you said get acidification. That's because this was modeled. No, it's a good point because the guide was modeled on something we did 10 years ago, which was the guide to best practices ocean acidification research. So it was really an inspiration. That was a document that was kind of catalytical for the ocean acidification science community because it really brought the number of people doing research. It kind of lowered the entry level, let's say, to start ocean acidification studies. It was really important to be able um, to build this ocean acidification community that we talked about earlier. And right now, maybe there are 100 scientists only looking into ocean alkalinity enhancement, and it's not enough because businesses are already looking very much more into this than academia, and it needs to be more balanced. So um, this guide was made in the hopes that it would have a similar catalytic effect, let's say, on this field of research, and that really it's advocating for sharing data also from private companies who are doing really probably very good research, but it's not always transparent, it's not always shared. So that is this guide. It has 13 chapters. It's looking into the chemistry, how to get the chemistry right if you want to do ocean alkalinity enhancement, how to um, do data management and sharing, super important, as we said, and what are the impacts, as you were saying, super important. What are the impacts on marine life and biodiversity? So yeah, it's happy to share the resource with anyone interested. Maybe I don't know if we're going to continue on this subject or you want to change.
I would like to take this subject a step further and to give it a more regional focus. So since we are in a side event on the Gulf, on Mediterranean and also Persian Gulf, so what do you think could regional networks play in further understanding ocean acidification solutions or alkalinity enhancement solutions for particular regions? As we understand, it's only feasible as a small scale, if at all, as a small scale regional or local solution. So, what could regional networks do to facilitate or to help to better understand? What's your opinion?
Thank you very much. I think about the regional network, I think one of the issue which Steve mentioned and probably what we like to highlight is measurement is not enough. And I personally, since we are a resource, not it's a resource intensive exercise to generate high quality pH data, which I have always disagreed that I don't have resources to do this. A spectrophotometric pH measurement doesn't add much to my understanding. So, what we sincerely believe is that we should start investing time and energy to understand that how these organisms are actually, what is the biological aspect associated with it instead of the only chemistry. Because at the end, we are going to look at the ecosystem functioning, the resilience, and this is very, very nice to do and invest in this because the experimental data so far that has been generated, I'll say it has been generated in haste. There are experimental studies which just take the uh, CO2 levels from 400 ppm to 900 and 1600, and we very easily conclude that they won't survive, they won't make it. We have done quite a lot of work, and I can we have had some discussion with Steve that probably Gulf is a good experimental site in that terms because it's a very hot water. We are super saline. We do see a lot of a much accelerated drop in pH in spite of all the buffering capacity we have. But we still see ecosystem resilience and uh, work which we have been doing experimental work to support this. We see that this is like inbuilt. So are we really underpinning it with the right science, these policies, or really we need to be very cautious when we say that, because what we can all agree that yes, extreme events are increasing, but are they really going to have this devastating effect? I think I have serious concerns about it unless we underpin it with some solid science, and that solid science is still lacking. So that's my take on it.
And sort of picking up on what you said around the importance of sort of regional hubs. I mean, from the ocean acidification viewpoint, I mean, what we've really benefited from by creating the regional hubs and having the regional hubs created not from a global perspective, but actually from the ground up. The scientists in the region creating a network that was by them and for them to discuss the issues that were most relevant to the situations they were looking at, to be able to share knowledge. So some of the regional hubs in Goan have a much stronger focus on capacity building, some on particular habitats, some on technology development, and it's very much about what is of interest in that region. And I think that's the value. There's huge value in coming together at a global scale, but let's not understand the shared experiences of people who live in the same kind of geographical way, dealing with the same governance and management issues, dealing with similar environments, similar ecosystems. That kind of shared experience is so important, and also in terms of sort of being able to accelerate the knowledge exchange as well. Particularly in very resource limited situations, it's important that we get every last piece of value out of the knowledge we have. So
Can I add on? Oh, you go ahead.
Then Jessie, please.
Oh, sorry, guys.
I just want to add that maybe there are shared experiments, but also the difference. Because for the Mediterranean, for example, we have on the north developed countries that are part of Europe, so they have more finance, they have more capacities to adapt. And in the south, it is different because those countries are more impacted by climate, they are more vulnerable, but also they receive less financing possibilities, and they cannot manage it. So this is also good when we have networks, because maybe the developing countries can explain to the north what is going on in their country, what are their difficulties. And for the science, what we need is maybe more monitoring and data that we as economists can use in the future. Because the problem is most of the scientific experiments are done in laboratories for very short term periods. And for economy, we need a longer period, we need more data to make the modeling and to forecast what is happening in the future.
Jessie, would you like to add?
No, that's okay.
Okay. Thank you very much. So let's take it a little step more concrete, a little step further. So what would be the steps that would be needed to mitigate ocean acidification impacts on food security in the Red Sea, Gulf, and Mediterranean? Jessie, would you like to
Yes,
take that?
indeed. So yeah, I mean, I think the questions are what steps are needed to mitigate OA impacts on food security in the region, and the answer is many. And of course, I'll be speaking from the policy sort of management side. But before that, I just really want to hone in again on where we've been talking about the biological impacts studies, and because that's really where the nexus of the food security conversation starts to come in. And just simply put, worldwide, there is not enough biological research in most places to even determine potential impacts of OA on keystone species and food webs, and therefore food security. And that really does need to change. And the IAEA has done a phenomenal job actually putting research agendas out into the world focused on keystone fisheries. And I know that the report maybe is just out looking at 17 different seafood species, and we need to see more of that out into the universe. What I'll say generally is that I think from a food security perspective as well, we really need to be moving beyond shellfish, right? So we've talked about OA sort of becoming like an oyster issue or a mussel issue. We really need to be talking about this as a food web issue, as a habitat availability issue, and as a fin fish and fisheries issue. And it doesn't just have to be about shells and skeletons, right? So it really is thinking about life stages, growth rates, habitat compression, especially in the context of multiple stressors, as we talked about with warming and hypoxia, which I think is as important, if not more important, to the region that we're talking about by way of impacts. And so, so again, kind of looking at some of the localized species, bluefin, sea bass, urchins, coralline algae was mentioned, and different species studies around that. Um, I think from the policy side and bringing more of that focus into the food security work, we do really want to be talking about changing ocean conditions, climate related changing ocean conditions, warming, hypoxia, ocean acidification is going to have an impact on different sectors. It's not just fisheries, but it's also aquaculture, tourism, coastal management, sustainable development goals. And that all sort of has contact to economies at scale and food security economies. And as far as, what we need this integration to look like, we need a lot more integration between government sectors and public communities about what's required to make a meaningful mitigation and adaptation agenda for coastal waters in one region. And that really is going to look a lot like marine conservation. That's going to look a lot like decreasing local stress. And that's going to look a lot like building resilience. We've talked a little bit about the blue carbon or nature-based solutions sort of approaches. And I think that's sort of what the agenda looks like, if you will. I just want to add a couple things. The UNF, there's awareness growing generally about ocean acidification, I think. Um, how has that translated to real action? That's a different question in the mitigation and adaptation space. And I think the biggest question is because most policymakers just don't know what to do. We were having a conversation the other day with a minister of foreign affairs in a country that I won't name. And she said, yeah, we're preparing for the UN Ocean Conference. We're going down the targets of SDG 14, which includes 14.3, which is the ocean acidification goal. She said, we get to that goal and we just skip it because we don't know what to do. And then we keep going. And I thought, man, everyone does. Of course, like that is not unique to that location. And it's really on us to help policymakers understand what they can be doing and why it's so relevant to these topics like food security. So I think you need to be able to set that table before you can get into the mitigation and adaptation strategies. And so particularly like what do we need? We need a lot more funding at different scales. Some of that can look like international funding from groups like GCF or JEF or development banks, and making the case that ocean acidification work, all of which we've heard about different flavors of that today, is part of a climate adaptation agenda and is part of a food security agenda. And that is a really important case to be making. The second is, again, the focused regional research that we talked about, groups like OR's, FAO, calling them a little bit more into the work to think about seafood species research that they could be doing in this context. As well as the regional conventions and OA networks that we talked about. It shouldn't just be on OA networks regionally to be creating an entire seafood vulnerability research agenda. It's not possible. It's not time sensitive. And we have other bodies that we need to be calling on for that type of work. And then we really need policy and management integration in a real way. And so I think what that looks like a little bit is we're more relying on cumulative impact assessments, thinking about local CIAs that include hypoxia and ocean acidification. That helps make the case for reducing local stress a little bit more strongly. I think we talk about conservation like marine MPAs, but also marine spatial planning. So, what do we know about different locations coastally where there's going to be hotspots that are more acidic or more under more stress during certain periods of time? Do we know that there's growing operations or transient species that are going to be in certain areas and that we can manage around them better, and really using MSP in a more strategic way when it comes to thinking about reducing stress on seafood uh, species. And then thirdly, we talked more about just incorporating OA across more traditional climate risk assessments, blue economy plans, blue seafood security plans. How many countries have that? How many countries have a high level panel on ocean or ocean sustainability with a strong emphasis on seafood economies. And OA is absent, all of those plans. So those are the type of policy linkages that we need to be making. And then as far as the really localized strategies, I mean, we've talked about the blue carbon, nature-based solutions, reducing stress, breeding for tolerance, some of the manipulation biologically that you can do. But I'll leave it maybe to these guys to talk about that in a different context.
Thank you very much, Jessie. Anyone from the panel would like to add? Yes.
Yes, maybe we shouldn't consider ocean acidification separately from other stressors. It's all the stressors together affecting our lives, affecting our well-being, and I think they should be considered together. And same for the food security is one of the SDGs, but all the 17 FDGs are related. So we also have to consider them together if we want to advance. And so I think it is important to consider all the aspects as globally. And even if we consider only the Mediterranean or the Gulf countries, we can also look what is going on research globally and try to implement the solutions. Sometimes it works, sometimes not, but some of them can be useful, and we have not thought about them in the region. So I think this is also something we can do. And funding, maybe I can add something because I agree with Steve. Funding for research is lacking, and we need more research. And Jessie said also we need more funding for the solutions. But now we know what is missing is a private sector funding, because we have multilateral funding, we have public funding, and we want to attract the private sector funding. And one possibility is the blue carbon and what I said, the carbon market. But we should be careful about the marine CDR and not to do something which is not resilient, which is not sustainable for the future, because it is something we don't know. The side effects are not well known yet. And I think my scientific colleagues already said that we need more research. So we need probably more funding for that. So it should be attracted in the right way.
Thank you. I fully agree. In terms of funding, we should also start to explore the private sector possibilities of funding for our research. Well, it not always leaves us the freedom of what we are doing, but we should carefully look into it and explore that part. Now I would wanted to open the floor for questions to the audience, but I see that the audience is rather thin. But nevertheless, are there any questions from the audience to the panel? Yes, please.
Hey, my name's Callum from Australia, so different part of the world. But I guess my question, bit left field, why do you think the ocean isn't spoken about more in conferences like this or prioritized in regards to how important the role that it plays in climate?
Can I start? Can I start? It's a wonderful question. And I think I'll take the non-cynical answer. And then if anyone else wants to take the cynical answer, they may. But the non-cynical answer, I think, is just true awareness. We've been part of a group's, I think, present company working to elevate the role of oceans in at least the UNFCCC, International Climate Agenda, since about well before Paris, but really picking up around the Paris Climate Agreement. There have been many partners like Plymouth, like Prince of Monaco Foundation, IAEA, that for years, as early as the early 2000s, were waving the ocean flag in the UNFCCC space. From my perspective, because that's when I arrived, everything picked up in okay. But what I perceived when I began working on this topic here was around Paris Climate Agreement time, there was more of a massing of civil society groups really focused on the ocean agenda, if you will, and trying to reach out to governments to better build a ocean caucus here at the UNFCCC, parties getting together, having particular demands around how we are better reflecting ocean mitigation adaptation impacts at the UNFCCC. That has now developed into something called the UNFCCC Ocean and Climate Dialogue. They have on their third annual meeting, they meet at the SUBSTA, which is the subsidiary technical body on science advice to the UNFCCC. And I think it's finding its way. There is still, I think, misunderstanding to some extent around the role of the UNFCCC and some of the ocean work. So, of course, from my perspective, and I think present company here, we're thinking about the impacts of greenhouse gas and carbon emissions, right? Which is the number one charge of the UNFCCC is to reduce impacts caused by those things. And ocean acidification is squarely within that basket. And so that's really what we're trying to make the case here is that the UNFCCC has even existing responsibilities to the mitigation agenda, to the adaptation agenda, and to the financing around ocean acidification. Just to give you a quick example, this year's Ocean Dialogue picked two themes. They focused on food security and something else, blue carbon. And so the blue carbon agenda is more or less straightforward. It's not easy, but we know what we're trying to get done with blue carbon. We're trying to map it, we're trying to measure it, and we're trying to account for it in our NDCs or monetarily or count it in our reduction goals potential. From the blue food side or food security side, the big conversation was still around, yeah, we just need to reduce emissions from the fishing sector, and that's one way that we can address food security. And while that's one approach, it certainly misses the entire adaptation conversation that we've been having. And so I think there's still a long way to go to bridge that understanding around really the scope and scale of what we're talking about when it comes to warming, acidification, oxygen loss, and impacts on these species and ecosystems. I'm very passionate about this topic, so I'll say one more thing. I think, again, the optimism is that it's not that people don't care. It's really that people don't understand. They think of ocean acidification as an open ocean observing issue. It's not in their EEZ. It's nothing that they have any personal control over. And so there's just no way that they can think about tackling it. And I think it's not pessimism. It's really just a barrier of communication. And we together as a field of practitioners are continuing to refine the messages and the calls to action of what can we be doing about this now. And I think as that continues to resolve itself, we will see more momentum and interest picking up at international, regional, and local scales. But that's the optimistic perspective that I have, and a hold.
Steve, would you like to add?
To give a comment on that. Yeah, if you think it's bad now, you should have come here 15 years ago. It was dreadful. It was awful, as Jesse said. The ocean was nowhere near the agenda. But I do think I think it's moved forward. And I would also like to highlight the role played by some of the small island states in moving it forward, because inherently their cultural ties to the ocean are so much stronger. They in essence, they get it immediately because it is part of their life, their culture, and everything. I come from a city in the southwest of the UK, Plymouth, which is a coastal city, and was called the city that turned its back on the sea. It was ridiculous. We have children who live 2 or 3 kilometers away from the sea, who've never been to a beach because it's not what people like us do. This is what other social classes do. And I think there are some countries where we're dealing with large barriers to people's sort of engagement perception of the sea as something else. So we don't engage with that, which is why the small island nations have always been at the forefront of getting the oceans on the agenda at places like at the UNFCCC and at CBD and places like that. I would also slightly warn against the narrative that has started to spread around the ocean is our solution to climate change. Because yes, there are activities that are going to take place in the ocean which are going to be incredibly beneficial for us, but they've been going on for multiple years without us knowing. The ocean has tempered the worst extremes of our activities without us even acknowledging that and without us even appreciating the damage we've done. We seem to still be in this relationship with the ocean like it's some kind of rich spouse that we're going to tap up for whatever we can get from it all the time. When really the communities that are really championing for good ocean action are those that see the ocean more as a parent that cherishes us and looks after us, and we in response have to cherish that parent back. So whilst I agree that the ocean is full of potential in how we're going to manage big environmental problems, let's not keep exploiting that resource, but let's be mindful that we need to love the ocean in the same way the ocean has loved us for thousands of years.
That's a great statement. Natalie, would you like to add?
I will second Steve and Jesse because really the ocean has been seen as a resource provider. If we consider the blue economy, we see it as fisheries, maritime transportation, or tourism, coastal tourism, marine tourism, etc. And even the minerals and the oil and gas, which is in the ocean. But what we need now is to have a paradigm shift and to change our view on the ocean and on the nature in general. We need a regenerative, nature positive economy. And this is something that we have to have in mind if we want to continue, because the ocean is not only something to give us the resources, but it's a part of the solution for climate change and for mitigation and adaptation.
Thank you very much. These were three great statements, and I hope your question is answered. Is there any other questions from the audience?
Thank you. Really, thank you. Very interesting discussion. And I'm just thinking about what can we do more together. And thinking of at the beginning of this week, we worked with Kuwait on a boat vessel, research vessel, which is, I don't know if you have visited, but it's right here in Dubai. And thinking about what you have said about baseline data, that's many places we don't know what's going on, and how we can contribute to this with Kuwait, particularly in the region here, where desalinization is very high, and that maybe give us another perspective where the salt is going back to the sea. So, what would be the impact when we are talking about acidification? You see what I mean? So I think that's something that we will maybe contribute in the future, and we hope that we have everybody there working together.
Thank you, Najat. This is almost like a summary statement of this nice session. I would like to thank all of the speakers on the panel: Lina Hansen, Steve Widdicombe, Jessie Turner, Natalie Hilmi, Montaha Behbahani. I'm sorry. And I would like to thank the audience. And before I close the session, I would also not forget to mention that the funding for the Ocean Acidification International Coordination Center to a large extent is extra budgetary. And we're really grateful to the United States for funding since 2012. Thank you very much. And thank you very much for this great session this afternoon. Emily picture.